So for Lab 9, we performed a 1-chloropentane synthesis, or an SN2 reaction. The professor, provided the procedure video, so we were able to see what really happened. And we were given from that experiment our actual yield of 1-chloropentane, which was 0.91 grams. To get our theoretical yield, we use this formula down here. We were started out with 2 milliliters of pentanol, and we want to switch. We want to see what we end up with in grams of chloropentane after starting with our pentanol. So to get that, we take our milliliters and use the conversion grams per milliliters of pentanol, and that we get from the periodic table. And then multiply that. We are going to now convert it to moles. So again, our 88 grams of pentanol to 1 mole. And then our ratio of moles in our reaction, so pentanol to chloropentane, which is 1:1. And then lastly, our how many grams of chloropentane to mole ratio we have. And basically we take our 2 milliliters and multiply it by everything on the top and then divide it by everything on the bottom. And that gives us our 1.96 grams of 1-chloropentane. And then to get our percent yield, so that was our theoretical yield. So what we calculated we should have gotten from this reaction. In reality, we got 0.91 grams of 1-chloropentane. So to figure out our percent yield of what we actually got, we take our actual divided by our theoretical, multiply that by 100 to get a percent, and we were left with 46.4%, which was our percent yield of 1-chloropentane. And then I need to go over how we can determine SN1, SN2, E1, and E2 reactions. SN1 and SN2 are both substitution reactions, but SN2 is a reaction that occurs simultaneously, so there's one step, but there are two things reacting at the same time, so it's a bimolecular reaction. So in this specific experiment, what happened was our alcohol group on our pentanol, or our hydroxide group on our pentanol, the OH, those electrons combined with our acid, or the hydrogen from our hydrochloric acid. So that turned that hydroxide group into a water, which made it a good leaving group, and it came off that carbon chain. And then we're left with our chlorine from our hydrochloric acid. And then at the same time, that hydroxide group takes that hydrogen and leaves that molecule, the chlorine, then bonds to the carbon chain, giving us our product of 1-chloropentane. So that's how this specific reaction worked. An SN1 reaction is a unimolecular nucleophilic substitution that produces a carbocation. So we're left with a carbon chain with a charge on it. In an SN2 reaction, you will have a neutral base. No, I take that back. You'll have a charged base, something with a charge, so that hydrochloric acid would have a charge on it. And SN1 would be a neutral. And then for our E1 and E2 reactions, E1, again, like SN1, it's a one molecular elimination where the nucleophile acts as a base, and then our two groups of hydrogen and a halide are lost. And then E2 is a bimolecular, just like the SN2, but it's an elimination. And the proton, sorry, you're not really looking at anything exciting. Here I am sitting in my steady, fire going. But we can see here in our notes where I took, that are, here we go, we can keep looking at this lab. The E1, like the SN1, is going to create a carbocation, so we're going to have a carbon chain with a charge. And again, we would like a neutral base to react with, whereas E2 is more like SN2, and we want a negative base, and usually they're stronger bases, and it can get bulky. So I think that gives us the difference between those two, so I think that will work. Alright, thanks, bye.